Hey guys, a very good morning. Am I audible here? All right. Okay. Good morning to all. And so, guys, let's give 2 minutes for everyone else to join. So, good morning, everyone. And so, as I told you guys yesterday, today we are gonna be focused on Keras. So, first of all, a very warm welcome to this second session of the webinar, and where we yesterday kind of saw what is TensorFlow and what are we supposed to do with it. And today we are going to be focused on a deep learning based library, which is a part of TensorFlow now. Okay. And today we are going to be looking very deeply into this, that how the idea of Keras works and what we can achieve using Keras. Okay. And why it is preferred, as a matter of fact. Okay. So today I'm going to be mostly looking into this specific idea that what is Keras and why do we require that? Okay. So first, let's look into how Keras works. Harsha, I think we are too early in dealing with use cases. You guys are very new in this one. I will give you some ideas that what we can do and how we can build things. But it's gonna be tough right now to implement because, again, as I told you, these webinars are no substitute to a full class. Okay, so right now we are trying to keep it very light here. But if there were to be a full class, it would be much more intense and a lot of background knowledge is required. So I will try to keep it light. I will try to give you some examples, but no, unfortunately, we cannot work on a use case because that would be too hard right now at this moment. Okay, all right. So first, let's talk about what is Keras itself. Okay, it's like Python deep learning library, or it's like a Python deep learning API, if I have to say it like that. So guys, how many people know what is Python, first of all? And you guys can answer directly on the chat. I'm looking at the chat all the time, so I should be able to see your responses. So guys, do you know what is Python? It's a programming language. Yes, perfectly correct. It's a programming language. Yes. So the idea is TensorFlow is there. Okay. So let me show you what do we really mean by this. So TensorFlow is this mathematical framework. You can call it like mathematical framework. For machine learning and deep learning, right? Okay, so TensorFlow is this mathematical framework which helps us or supports machine learning or deep learning, right? But the thing is, still in TensorFlow, if you had to code your own neural network, there are far too many steps. And it would not be very different from what we would have coded in NumPy either. Okay. So at around 2014 itself, Keras was being developed. Okay. Now, initially it was being developed for Theano, and you can understand Keras is just like a wrapper now, was a wrapper at around. And TensorFlow came in 2014 and Keras already started supporting that as well. So it is like Keras is kind of this layer, API layer that talks with TensorFlow. Now you have to understand Keras itself does not do any computation. Okay, most of the computations are actually done by TensorFlow. Keras is just like a message passing system. Okay, Keras will take input from you. It will just do some kind of transformation. Okay, but all kinds of main calculations have to happen at a TensorFlow. Okay, this is very important because guys understand Keras in itself is not really a deep learning library, if I have to say that. It's just an API. Okay, it's not really a deep learning library. It's just an API that we are utilizing, okay, to talk to TensorFlow. That's all it is. Is that part clear, first of all? Okay. So in this scenario, why do we like or why do we prefer Keras? And you will see the amount of code that we have to write to design a neural network becomes extremely small. Now, unfortunately, we don't have the luxury of time in these webinars to explore like where Keras is going to show you acceleration or not acceleration, where it is going to show you ease of use. But I will show you some code today, and hopefully that will make sense. Now, around 2018, if I remember correctly, Keras was bought by Google. So Google bought Keras. Okay. So basically, in 2019, what happened is, sorry, Google. In 2019, rather than Keras being an independent library, it became a package, or it became a library or a sub-module or something, anyways you want to refer. And now we have started calling it TF Keras. TF.Keras, it simply means you have TensorFlow. Inside that, there is a library called Keras. And TensorFlow has really promoted TF Keras for deep learning. So all kinds of neural network work, they want you to focus on Keras, okay, for deep learning or any kind of work. And the rest TensorFlow is also there. If you want to create some kind of a system on your own, that's also okay. They have no problem with that. Okay. You can also create these things on your own, and they have no problem with that. Okay. But they have focused, or they have told us to focus, or not told us, it's like given this intuition that if you want to design these complex systems, you should be looking very deeply into Keras, as a matter of fact. And this is what we are going to do as well. We are going to look Keras in order to build neural network. But please understand this. And again, I want to be very, very clear. Keras itself is not doing any kind of computation. Okay. Any kind of thing that you design, Keras is just helping you design things, like, let's say it is helping you out with the design processes. Okay, that's what it is really doing for you. But inherently, please understand, it itself hardly does any computation. All the computation is still happening in TensorFlow. It is just a wrapper around TensorFlow, and it helps you write the code faster. And also the code is smaller as well. Like, you don't have to write as much code as you would have to write in TensorFlow. So as we say, Keras is the high-level neural network API, not a library. API, we are particularly mentioning it. Written in Python and capable of running on top of TensorFlow. This is the default one. Although one could run it top on CNTK and Piano. Hey guys, if you're not talking to me directly, please mute yourself. It was developed with a focus on enabling fast experimentation, that if you have an idea, you could develop a small neural network or test that hypothesis out really fast. Okay, and basically the idea is it allows for easy and fast prototyping through user-friendliness, modularity, and extensibility. Okay, and then it also supports a lot of different kind of neural networks, like convolutional networks, recurrent networks, and combination of these two as well. Okay. And it runs seamlessly on CPU and GPU. So yes, it can be run. The code written in Keras can be run on your CPU, or it can also be written on GPU as well. Okay, so all of that is true, and that is something that we are interested in. And as I already mentioned, Keras itself does not do any major computation. Okay, so TensorFlow is this backend. If I had to represent it in a slightly different way, so let's say the TensorFlow is the code backend here. And Keras would be some kind of Keras would be some kind of a message passing system. Okay. And so user will deal with Keras. Okay. So user will deal with Keras also. So let's say you are the user and you want to design some neural network. Okay. So you will have to deal with Keras. Keras will pass this information to TensorFlow. All kinds of computation will happen at TensorFlow level. And the results would be again passed back to Keras and then to you. Okay, this is the major point that we are interested in. Till this part, do you have any questions? Clear, very good. So in order to kind of navigate or not to worry about how things work, or how overall ideas work around TensorFlow, one could directly go to Keras and try to learn Keras, but understand having a basics of TensorFlow, what we covered yesterday, would really help you in understanding what is TensorFlow, Keras really doing. and how Keras is achieving these results. Okay. So actually, nowadays, we don't have to import Keras separately. The moment you imported TensorFlow, Keras has already been imported. Okay. So one of the simplest reasoning I will show you. Let's say if I were to give you this task, okay. I were to ask you to implement this function on your own. So ReLU is like a nonlinear activation function that we utilize, and it usually looks like this. Okay. So in the negative, it is 0, and in the positive one, it becomes y is equal to x. Okay. So you could write a Python function. Now, ReLU function usually does not exist in NumPy or Simple Python. Okay. Now, of course, you guys could write your own function. Okay, I'm not denying it. You could definitely write these functions on your own, or we can go to tf.keras library. Okay, we can go to tf.keras library. 1 minute. So I could go here and I could say, let's go to tf.keras. Now you can clearly see they have these versions available. And here you will see they have a lot of these functionalities also available to you. Okay. So let's say I go to activation functions. Okay. So a lot of activation functions are available here. And I'm like, okay, I am interested in ReLU function. Okay. I can directly go to ReLU. So tf.keras activation.relu can be utilized, and where we could pass the value of x. And based on that value, it would be giving you the outcome. So let me show you what do I really mean by this. Guys, imagine this is an array. Okay, so first we'll have to do the import here. Okay. One more thing I will do right now is I will share the link of this notebook to you guys. Okay, so guys, in ReLU, what happens? What is going to be the outcome? So this is an array where we have multiple values, -10, -5, 0.05, and 10. So what is going to be our outcome? So you will see the negative ones will basically inherently become like 0. And let me show you the outcome. So rather than me writing a function, now I know the function is not that hard. We could write that function easily. But here, what we are seeing is for the negative ones, because ReLU is inherently anything 0 or lower than 0 is 0. And beyond that, whatever the value is, it will be kept as it is. So I could write my own functions, but it would be far easier if I could just bypass this and give this task to Keras, and Keras can again give it back to TensorFlow, which will do all the processing. Yeah, exactly. Similarly, if I ask you to implement the swish function, then how will you implement it? So there is another activation function called swish. So it usually looks something like this. Now the problem with ReLU is it turns anything negative into completely 0. And many times we don't like it. The swish function should go something like this. And inherently here, it is very much like ReLU itself. So if I had to implement swish function, how would I implement it? And again, someone can do this implementation on their own. So swish is nothing but swish function usually is sigmoid function. So you can do sigmoid function. Hey guys, do not annotate on my screen, okay? You are not allowed to do that. So please don't do that. Okay, so swish function is inherently 1 minute, please, sorry. So swish is like another kind of activation function that we utilize. Okay, and that is a sorry. So basically, 1 moment, I should have written it clearly. X dot sigmoid of x. And this makes your Swiss function. Okay. Now again, if you want to implement it, no one is stopping you, you can implement it. But if you ask me, I will simply say, why don't we just go to Keras activations and just apply switch on that input. Okay, whatever the input is, I could just apply that. And then I will get the values, and you will see that for negative values, and the values are so really small. And for the values like 5, the answer is 4.96, which is very close to 5. And even for 10, the answer is 9.9995, which is again very close to 10. So you can see that we are able to achieve, so its performance could be even a little better than ReLU function. But again, I don't have to write these functions. Yeah, Harsha, in some scenarios, Swiss actually does works better than ReLU function. Okay. So this is the speed up, or this is like the, we are talking about, this is the advantage you are gonna get if you were to try and deal with Keras rather than trying to write code on your own all the time. And this is why we require framework and libraries, so that we don't have to go ahead and define everything. We don't have to go ahead and define everything on our own. So this is something, this is amazing if you ask me, the way we are working. And this will reduce a lot of tasks that we have to do while building a neural network. Now, again, going back to neural networks, let's try to understand what do we mean and what do we really require. Now, the neural network, if you remember, last time we talked about this, the last webinar that, okay. And we have these layers after layers that we design, and each of them have multiple nodes, and there is nonlinear activation over them. So each collection or one of these collections you can call layer. Okay. So let's imagine this is layer 1. Okay. So now it needs to have its own weights. So it will have its own weights. There would be a bias term as well. And there would be some kind of a non-linear activation. Let's say for our side, we say ReLU is there. Okay, so like ReLU is like one of the activation functions we are interested in, right? So we have to define these things, okay. And we will have to kind of give this definition while building the neural network. Now, again, one could do that by simple matrix operation, and it's doable, no doubt. You can do matrix operations, or let's call them tensor operations, okay. And one could definitely build this very much on their own, okay. But that will be very, that will be time-taking process, and it could slow you down. So if I want to speed it up, what I could do is, we could try to think that, okay, Keras will have these libraries available for us, right? Okay, so the very first class that you need to know here is called layer. Pretty much everything that you deal in Keras kind of derives from it. So layer is at the core of all the other organizational paradigms that we have in Keras. Now, Keras layer kind of is again gonna be extra kind of extended, like we will extend this idea of layer as much. So TF Keras layers.layer is the one, is the path that we have to utilize. Okay. So layer is a class that implements a common neural network operations such as convolution, batch normalization, dropout, okay, or max pooling. These operations require managing like weights, losses, updates, and inter-layer connectivity. Okay. So what you have to really do is you have to instantiate a layer and treat it as a callable. Okay. So it's like you initialize and then you call like a function. Okay. So in it, so there are 3 things that are required. Okay. In any layer definition, 3 things would be required. Init is kind of like a constructor. Okay. Init is like a constructor. Which saves the configuration in member variable. So any kind of initialization that you want to do would be saved here, okay? And we can utilize this. And then we are looking into build. Okay. Now build is where you will be utilizing, or you will be passing out the shapes and the shapes of input and data. Okay. Build is like kind of containing this information about whatever we are building, whatever the layers we have, and what to do with that. Okay, so that is what we are utilizing. Okay, that is what we are trying to utilize, and build will basically tell you the shape of the layers and what are the values that we are utilizing. The call function is the one where the actual logic is written. Okay, in the call function, we perform the logic of applying the layers to input tensors. Okay, so whatever information we are getting, we are utilizing that for our purposes. Okay, so let's see how to build this one. Now, because I have imported TensorFlow as TF alias, I should write tf.keras.layers. So let's say I want to do something very simple here. Okay, let's say I want to do something very simple here. I want to build a small matrix operation. Okay, let's refer it as linear layer. Now, in linear layer, the idea is really simple. What we tend to do is we require our weights. Okay, Wij, let's say here, and you have to do the dot product. So that's why I put the transpose over, and then bias as well. So this is a simple linear operation that I want to do. So any input that's coming, this is the input data. Okay, I want to multiply with their weights and then add the bias term over there, and let's refer it as a linear. Now, it's not that I really require to make this available. I could take the simple dense layer in Keras and I could just choose not to give any kind of activation function over there. So if you choose not to give any kind of activation function, that's like providing the or telling it the activation is just the linear system itself. Okay, so that is already available, and that should be really straightforward. Okay, but let's say if you had to construct a custom layer for this, what you will do is first you will import layer and you have to extend this layer. Okay, this is called inheritance. In programming, we call it inheritance. It is gonna inherit properties of layer, which is gonna be provided via the Keras itself. Okay, 1 minute, guys. There's no module TF. What? We did run this one, right? This is a very weird error. No module. 1 minute, guys. Maybe there is some issue. Let me just see if I can just re-import this thing. Import TensorFlow as TF, right? So I think we did this, but let's see if. Okay, let me try something. Okay. Okay, I think it is not supporting the alias. It wants the whole name. Anyways, we have provided the whole name here. So TensorFlow.keras.layers, import layers. Okay. Okay. Now this layer would be extended into the custom layer that I'm going to write. Let's say linear. Now guys, understand this is not really required. Okay, I'm just giving you a sense like how things work here. Okay, so first I could come up with an init. Init is nothing but like a constructor. So if you have worked in C++ or Java or C#, you would know what is the constructor it is like to utilize to initialize the variables that we have. So what we do is we provide number of units and input dimension. Okay, and then we choose to initialize the W. Okay, so let's say W is initialized, and usually weight initialization is some kind of a random normal initialization. Okay, and we define that W is going to be a variable with shape of input dimension into the number of units. It simply means input dimension into number of units of the that layer. Okay, and then data type will be float. And if you give trainable as true, what it means is we would be able to change the value. Okay, trainable is equal to true is in the process of training the model, we will be able to change the values of W, and we do want that. W and B should definitely be trainable. And B, you could initialize with zeros as well. You don't have to really go with random initialization here. And here we see that again, we do the conversion, we provide the number of units, and we have this information. And then we have this self.b. Okay, so basically W X, or you can say W transposed X plus B is available to us, right? So basically this is the operation that we want to do. So in it, we will only have initialization. But in the call function, what we do is we really write the logic. So could you see that what is the logic of, or how does it does the task? How, or what is going to be the return here? Like what I will get back if I were to run this piece of code. So you can simply say it is nothing but Wx or W transpose X. Matmul will take care of the transpose and adding the bias. Very good, yeah. And this is what I am referring as linear layer, okay. So guys, this is what I was trying to say, that one could build custom layers if they wanted to, okay. You could build the custom layers if you wanted to, as you want, okay. No worries, no problem here. And one could design this, but it's okay if you don't want to use this. Keras actually supports a lot of different kind of layers which can be utilized, and we could work with them as well. Okay. Yeah, exactly. So we can give you the outcome without the activation, and that will look like a linear system itself, right? So let me show you what do I mean by this. So here, so we do have layers, okay. So let me open the layers here first. Now the documentations are written very well, and I will ask everyone to always go through documentation once, okay. Now guys, any kind of processing you want to do, Keras has a layer for that. Believe me, like it's a very rare thing that you would require, like right now while you are learning, you would require anything that, let's say, Keras does not has or present with it. It's very rare, it's a rarity, okay. In all of these years, like for last 4 or 5 years, I have not found a single time when I found that, oh, Keras does not have this layer. No, it's mostly available. And even if it were not to be there, no worries, I will be able to create that layer, okay, with the knowledge we have. Okay. So let's say you wanted some kind of a convolutional 2D, okay. You want to do a convolutional 2D operation. So you already have a layer for that. You don't have to design your own convolutional 2D layer and write all the logic. All the logic is already provided. Let's say you were dealing with some kind of a LSTM, right? So even those, or convolutional LSTMs, even those are available. Or if you just want to use your regularly densely connected neural network, that's called a dense layer, by the way. So here, let's say if I wanted to use this layer itself. So you can see that we have number of units. We have here itself, we can actually pass the activation as well. So here itself, we can tell what to use: tanh, sigmoid, sys function, relu function, prelu, right? Different kind of activation functions are there. And yes, do you want to use bias? Yes or no, or like true or false. And then different kind of initializations are there, how to initialize the bias, right? And if you want to use some regularization technique for kernel as well as the bias, all of that can also be provided. So the good news is you don't have to design things from scratch here. You just need to know which one to call and how to utilize that function. Okay. And you guys can see we have so many layers. Like if you just want to put some Gaussian dropout, or if you want to just put some Gaussian noise, we have a layer for that. And let's say if you want to use LSTM. Now designing LSTM is no joke. Okay. It's a really complex architecture, and one could utilize it from it. Okay, all right, guys. Okay. So yeah, this is the whole point, that all of these layers are kind of already available, so you don't have to design things from scratch, and neither we will like promote that at this early stage that you start designing things from scratch. That really will not be our push. Okay, that you should know how to design these things, but wherever the layers and designs are pre-available, it's better to extend those functionalities into your code as well. So let's say we do that, and we will show you how to do that. Now, other thing is model itself. Okay. Now, what is this model that we mention here? Okay. Now, this model is basically, if I have to say it in a very simple way, it's a way to organize layers. Okay. I will say model is nothing but collection of layers. Model is nothing but collection of layers itself. Okay. So the core data structure of Keras is a model. It's a core data structure. Okay. It's basically a way to organize the layers. How do you want to organize the layers? Okay. And the one of the simple and simple model that I'm going to tell you is called sequential. Okay. Now, guys, what does the word sequential means to you? Yeah, sequence is one by one. So sequence, like let's say layer 1, layer 2, layer 3. All of them goes in sequence one by one. If you had to say it, it would be a simplest way of explaining. What do we really mean by this? Right, yes. So we will create these or connect these layers in a sequence, and that is what sequential model is going to do. It's just going to make things easier for us. So basically, let's say I were to go and from TensorFlow.keras, I would import sequential. And sequential, let's say I initialize and name it as a model. This model is that object, sequential object. And then again, we have wide range of built-in layers. Okay, and you can again go to the documentation and read about it. One of the first layers that I will be interested is in dense layer. Now, fundamentally, dense layer is very simple. There is usually some kind of activation function, activation. And inside you have your normal matrix multiplication. This is what dense will basically implement. It's like your proper. Functional APIs are utilized when you want to create something that is going to be different than whatever it is. So functional APIs are also available within Keras. That's a good question, actually. So I could use functional APIs in order to extract something more from them. So imagine if I want to create a parallel model. Okay, sequential is not good enough for me. I want to have some parallelization. So sequential will not support that. You can use the functional API to create your own function and use them as layers and everything, or use them as a different model design, and that will also work. But functional API should only be looked deeply into when you have covered the basics. You should not start with functional API. Yeah, this is like my feeling that if you start with functional API, many times you do not understand. Maybe things can be done in a simpler way, because again, a lot of functionalities are already available. So why don't we look there? But if nothing works, if the normal layers or normal designs are not working for you, then you should definitely look into the functional API. It's not a hard requirement. It can run on CPU, but if you were to specify the GPU, it will go and run on GPU as well. Okay, wonderful. So this is the first layer, or this is one of the layers that we should be using at this moment, because the rest of them would require some kind of understanding and everything, right? And right now we have not covered all that. So I would like to stick to something that we understand, and we can take simpler examples. Okay. Okay. Now there are different ways of initializing the model. Okay. So, and adding the layer to them. So one of the simplest way is the dot add function. Dot add function, or add function. Why I'm putting a dot in anyways. So you can utilize add function, and it's a simple rule. Okay, let me show you what we are doing. First, we will import the dense layer. Okay, and then we'll initialize the sequential model. And within that each model, model.add function, then you can have dense 32. Or anyways, you can just, you don't have to even give the input shape. Even this is totally optional as a matter of fact. And you keep adding these dense values or these dense layers. So if you add 2 dense layers, what it means is now we do have 2 layers where we have this our architecture that we could define, and we could have the processing, and these layer 1 to layer 2 is connected with each other. Okay. This is automatic, like you don't have to explain this connectivity. This is automatic, this will happen. Any doubt here? Okay. So why don't I show you how a small neural network is built, and then we'll talk about each topic, and then we'll try to make you understand what we are really trying to do. Okay. Now there are different steps, but I think the very first thing I could do is I could take example, and then I can come back and Asha, I think that's a very big question, and it's a very, like, how would I say, it's a targeted question. Like, okay, like unless I do not go into the context of NLP or CB, it would be a little tricky. But understand any of these domains that you work in, they have to be converted to numerical vectors. Now, how they are converted to numerical vectors is going to be hard. Okay, right now I cannot go ahead and discuss it in details because that will require a different kind of understanding how a text information is converted to vectors. Okay. Okay, very good. So there is a very famous data set, and I would like to show you that data set first. And this is good for explaining things. So let's say we have our MNIST data set. Okay, this is like your handwritten digits. Okay, so basically this data set contains handwritten digits which had been scanned, and you can see that the information is present here. Now, okay, so guys, when you look at any picture, what do you notice? What is the picture made up of?
Oh,
You guys can just respond in the chat. I'm looking in the chat, so no need to unmute yourself. Okay? Pixels, yes, very good. Okay, it is built up of pixels itself. Now the good news is pixels can be resolved to numbers. Okay. Pixels can be resolved to numbers here. So what do I mean by it? These are called grayscales. This is what we call grayscale. And let me explain what does grayscale even means for us. So grayscale has this rating or numeric rating of 0 to 255, where 0 is black. Okay, if you were to exactly go on 0 itself, it is pure black. And 255 is what? Okay, 0 is black, 255 is pure white. All the colors which are in between from like 1, 2, 3 till all the way till 254, they are like different shades of gray, basically, if I have to say. And this is why it is called grayscale. Like you are dealing in a grayish scale of the data. But the good news is any pixel, any of these information that you are seeing has been represented using grayscale information itself. So if that's the scenario, we could try to do something about it. And we could say, what if we were to convert all this information into numbers? Okay, now the good news is this data set that we will be using already has this scenario. So let me explain what do I really mean with this. Let's say I were to write like 0, okay? Let's say I were to write 0 here. Okay, and imagine the overall thing is split into various pixels, okay? So I would make an argument that the background color could be black and the foreground color could be white, okay? Or vice versa, background could be white, foreground could be black, right? So the good part is all of these can be resolved down to a matrix, and ideally the matrix should look like, so let's say the background is black, okay? Let's say the background is black. So let's say the first row is black, right? So what kind of information should we have over there? Numeric, if I ask you in numeric values, what could you predict to us? First row, most people I think would be able to predict that these values are going to be closer to 0 or maybe exactly 0. Okay, so maybe I will just write some values here. 0, 1, 0, maybe 2, maybe 3, maybe 0, 0, right? Because you guys can clearly see that it doesn't have to be exactly 0, 1 and 2. You will not be able to tell much difference over there. It's a very minute difference between 0, 1 and 2. They all look like very perfect black to our eyes, but there would be some variation. That's what I'm trying to say. But let's say if 0 starts anywhere, and let's imagine 0, the pixels of 0, wherever you see, are inherently white. Okay. Now white is gonna be much closer to 255. So if there is some information around 255, it should be something like 251, 250, and maybe I will take a circular scenario. So it would be like, let's say 245, and maybe now guys understand, a computer really cannot ever draw a perfect curve surface. It can give you approximation so that from far off it looks like curve to you, but it truly cannot draw a curve surface. It's not possible actually. And 240, 239, and maybe again 250 again, and so on. And in long run, you will start to notice we have been able to complete or come through a circle or circular picture. Does this make sense? Okay, very good. So the good news is in this data set, the numbers are already provided literally between 0 to 255. Now, idea is, or the question would be that using these numbers, can we do classification? So what we are saying is, can we do some kind of classification where we can have separate classification, or we could predict, is it whatever digit or whatever information we gave, which digit it revolves or which digit it is closer around, right? So we will have all the way from 0 to 9, so total of 10 digits, okay? So this is what the MNIST data set is all about, and this is what we are intending to use for this purpose, okay? Now, what we are doing is, in tf.keras, we do have some data set and MNIST is available between them. And it's a good habit, if data is already available, we could just directly load it from there. And we could load the data, and the data will be loaded into Xtrain and Ytrain. So the training set would be separate and the testing set would be separated out. Now the training set is like 60,000 examples, okay? Harsha, converting grayscale to RGB is going to be a little tricky. You can do that, but it's going to be a little tricky. But converting, let's say, RGB to grayscale is very easy. Yeah. So you will require some libraries. Python cannot do it directly. So there are multiple libraries. So one is called Pillow. So using some image processing libraries like Pillow or SK Images. Or the most widely open and known one is called OpenCV. Okay, so you can use the OpenCV one as well. OpenCV Python particularly. Okay, so you will have to use some third-party library to do all this part. Right now, with this problem that we are working, we can do it in grayscale, but with real-time images, yeah, having RGB information is definitely going to help us. Is that clear? Any doubt?
Is it like if we use RGB image, like we can capture more information and accuracy will be better?
Not just that, but yes, more information is definitely one point. Yes, it does have more information. But the other things is, a lot of image classification is very much built on colors and the difference of colors itself, like the shades and the curvature that we get, and many times the color difference matters. If you were to always bring it down to grayscales, a lot of color differences will get merged with each other. Let's say if you convert, let's say green and red, if red and green were next to each other, okay? And if you were to convert into grayscale, that information is not going to be very visible in grayscale. So yes, your classification might suffer a little. Okay, so what we'd like to do here is, first we download the data or load the data. Now we will reshape the data into 60,000 to 784 because, okay, Each image initially is a 32 cross by 32. So guys, 32, no, 1 minute guys, sorry, my bad, not 32, my bad. 28 pixels into 28 pixels. So total number of pixels would be 784. And this is why you can see I have reshaped the data into 60,000 rows, means that many data points into 784. So I have flattened that data from 2D to 1D. Now it is a good practice to scale the data. Now our range is between 0 to 255. So I've just flattened out or kind of reviewed, and now the outcomes are going to be between 0 to 1 only. Okay, all the pixel information, rather than from having from 0 to 255, I've scaled it down to 0 to 1. And basically what I'm trying to do is I'm also cutting down some samples from this training data, which I will use for internal validation. Okay, so I'm just cutting 10,000 data points, and that will be used for validation purposes. Now there is a task of building the neural network. Okay, so idea is I want to build a deep neural network. What does deep neural network means to us? It has multiple hidden layers. Okay, it has multiple hidden layers, and basic idea is, okay, so you have your input layer. Basically you have your input layer. Okay, and then you will need to have some more layers over there. So we have more hidden layers. So guys, what should be the dimensionality of input layer, if I were to ask you, or what should be the input layer dimensionality? Yeah, we can definitely go with your normalization and standardization or scaling in machine learning. Yes, you can do that, no problem. So input layer dimensions should be same as the dimensionality of the data. So let's say it is 784. So input layer has to be 784. Okay. Now understand, we are just saying input layer. It doesn't really has to be a layer like particularly. You could directly pass the data to the first dense layer itself. Okay, and then what should be the finality? Okay, or what should be the final outcome layer? What should be the dimensionality of that? Number of classes and output. Yes, perfectly correct. This one should have the as many outcomes or as many outputs you have. So based on that, let's try to design one layer or one model actually. So guys, we will start with sequential model, and you could directly pass the models rather than using add function. You can directly pass all the layers upfront. If you want, that's also okay. So guys, could you read this and explain me what am I trying to do? So you can see we have 4 hidden layers. The first hidden layer has 512 nodes, but this has ReLU activation. The next one has 256, has a TANH activation. Next one is 128, ReLU, 64, again ReLU. And the final one will have a softmax outcome. Okay. So we are constructing a deep layered neural network for classification purposes. Okay. And this is the complete model initialization. Yeah, it is ReLU, TANH, ReLU, and the final one, even I have not mentioned, but I will show you later. The final one has to be the softmax, because we do have a multi-output scenario. Multi-classification scenario, and softmax tends to prefer that. Don't worry. We will show you. Hey guys, you can see my video, right? Yes.
Yeah, we can see that.
Yeah, everyone can see. Can you check like is your internet connection all right? Okay. So the sharing is on. So hey guys, just can you respond on the chat? Who can see my screen and who can't? Let me just check it out. Because I was thinking everything is visible and people are able to see this. You guys can see my screen, right? Yeah, so sorry, what's the question here? Oh, Julal, so hey, if you are having problem in checking my screen, or if you're not able to see, can you just try to reconnect? Because everyone is saying their screen is visible. Asha, like we do not turn on video here. Like I hope you knew that. No, I was just mentioning about the screen sharing. Again, video, we do not turn on our webcams, okay? Sometimes it can be distracting for a lot of people as well. So that is one of the reasons we are not trying to do that right now. Okay.
Sir, screen is visible, sir. Like you just asked about the video, so like you got confused about it.
Sorry, what?
Like he just asked about video, sir. Screen is visible clearly.
No, Julian is saying screen is not visible to him actually. I was reading the chats and that's why I said, and that's why I started asking this question to everyone, that who can see my screen, otherwise how would you understand what I'm trying to do here? Anyways, so guys, this was the definition of neural network. Now some of you might think, oh, wait a minute, no one wrote softmax here, right? But the thing is, the last layer is the one where we will deal with the loss value. And to get that loss, we will use something called sparse categorical cross entropy. Now, cross entropy simply means log loss. Okay, it simply means log loss itself. Okay, and from logit sets, you are gonna get integer targets. Okay, you are gonna get some kind of integer targets. Okay, so we will get our logistic loss function. Okay, now if that's true, then we need to look what sparse categorical cross entropy does. So guys, again, if you have to calculate the loss, because again in machine learning we usually have some kind of a loss value which we are trying to optimize, right? So let's have a look. One moment. So let's go to tf dot Keras losses. You will find there is a complete module for this, a complete library here. And you have a lot of these cross entropy losses, and these things are available to you. Okay. So let's say I want to look into sparse categorical cross entropy. Okay, so let me show you what it does. Okay. So the good news is this one inherently is gonna do cross entropy. So let's say if you want to use labels using one-hot representation, then you can use categorical cross entropy. But if you want to give integers as your final outcome, 1, 2, 3, 4, 5, 6, 7, 8, 9, then we have to use, then we have to use the sparse categorical cross entropy. Okay. And fundamentally, what's happening here is basically sparse categorical cross entropy takes the last values or values from the last layer, applies a softmax function on them, and then only the calculation is implemented. Okay, then only the calculation is implemented. So that's why I did not write any kind of a softmax function separately, as you can see over there. Okay, and I can show you the source code as well. So the good news is these are open source libraries. So one could directly go there and one could see how the source code or how the code is written. And again, the code is going to look a little longer and everything. And you can see that it is inherently utilizing or kind of running the sparse categorical cross entropy, and sparse categorical cross entropy is defined here. And it is utilizing that to solve the problem. And internally, what it does is it applies that it applies that softmax function first, and then only the loss calculation is done. Okay. Ideally, then yes. So basically, what happens? It's not a rule. It's more of a like a guideline, if I had to say that. Okay, that as we will go across, as we will increase, you would require less number of neurons. Okay, so gradually there should be a decrease as we go forward. Okay. So basically, we use a sparse categorical cross entropy, and this is gonna be like some kind of a log loss. And then we are gonna use the term accuracy. We can use accuracy, recall. We can provide different kind of metrics here as well. Now the idea is like gradient descent is an optimizer, but it's a very naive way of doing things. And there are far better optimizers like Adam. Adam is provided or Adam is available to us. And this is like a far superior optimizer to whatever we have dealt with so far. Okay, so I am going to be using an optimizer as Adam. And the purpose of these things is again just to update the weights and biases. Okay, the purpose of these things is to update the weights and biases given from the last, whatever the last value was. But the Adam equation is fairly significantly different than whatever you might have seen in simple gradient descent. But the idea is same. Again, they are intending to do gradient descent. It's just that Adam takes different kind of assumptions. Okay. So now, guys, whenever you do this, two things are important. First, you have to come up with compile. So once you build the model, let's say you have come up with model, then the next thing you have to deal is compile. Now, what is this compile that we are dealing with? Okay, compile is where rules are given. Okay, you have to tell that which optimizer to use, which kind of loss function to use, and to evaluate the metric, what kind of metrics should be utilized to evaluate the performance of the neural network. Okay, so this is something that we will be interested in. Okay, and then we will have something different. Okay, what is that difference? We have X train and Y train. Okay, and fit. So if anyone has done some kind of coding in scikit-learn, they would know we use fit function to showcase that there is a trainable or training scenario. Okay, fit function is just going to show you there is something to be trained on, or training has to be done over there. Now you can give the complete training data, and it is also encouraged that we provide some validation data. And that is why we started separating, or we separated that data very early. Epochs is number of loops. Okay, number of loops. Okay. So the neural network takes a lot of time to train. Okay, it's not gonna be very straightforward, but right now we are gonna show you with only 10 of them. Okay, we are only gonna show you with these 10 of them. Okay, and we get our 10 epochs, and then we can also define batch size, that in one go, how many batches or how much information is required. Because many times neural networks are exceptionally large models, and inherently, if they are that exceptionally large models, then there could be a problem. Okay, what is this problem that I'm talking about? The problem is like it might not fit into the memory or video memory that you are utilizing or you're working. So many times taking a smaller batch, let's say 120 images, 128 images, or 128 rows of data, we go with at one point. And verbose one is a printout style. It will show you step by step how the training is done, loop by loop. Now, there's a relation between the batch size. So even per epoch, okay, epoch is like one loop, right? In per epoch, we will have multiple steps. In one step, let's say step one, only batch one is processed. Okay. In step two, batch two will be processed. So guys, if I were to ask you how many steps we will have per epoch, how many steps, like I have defined epoch, so we know that there are 10 epochs. So per epoch, how many steps we will have? One moment, guys. It all of a sudden chose to disconnect. No, number of steps is very simple. The total amount of training data rows, okay, training data size or row training. Divided by batch size. This is actually exceptionally simple. That will give you the number of batches or number of steps, okay, per epoch. Okay, very good. So once you do this, you could run the whole model. You could initialize the model and you can start running the training. So first it will download the data from this path. And you can see it has unzipped that data. Now you can see it has started to train the model. Okay. So in the first step or in the first epoch, you will see it takes a little bit more time because it has to load the data into memory. But beyond that, it's going to be pretty fast. Okay. Beyond that, it's going to be pretty fast. And if you have GPU activated, it will run really fast. You don't have to do anything about that. Yeah, the data is randomly shuffled. This is one rule that you have to remember. Data is already randomly shuffled. So guys, what do you see here? What is this first piece of information that we see here? Can anyone tell me? You see, we have started with the first epoch. It means 1 out of 10 is first epoch. We had 391 steps. Why 391 steps? Because total right now, after the separation, we had 50,000 training data points. And if you were to divide 50,000 by, let's say, batch size is 128, right? What is the number you are going to get? Not three, actually it will come some 390 point something, okay. But the thing is, it's a number of steps, right? They have to be integers. So basically it is always gonna be rounded up and we will say 391. Okay, anyways, so that's why you see 391 steps, means 391 batches have been processed one by one. Although it happens so fast that you must not have seen it, but if the neural network was pretty big, you would have seen that even steps, one step. It would have started at 1 divided by 391, then 2 divided by 391, and it would have step form. This is your log loss. This is your sparse categorical accuracy. But this is on the test training data, which does not mean anything to us. The one that you should ideally look at it, one minute, guys, is this other piece of information about validation. So initially, once you will start to look at it, you will start to see the performance takes some time and the loss ideally should go down. So loss is going down, right? And the performance here, accuracy should go up. And you can see that within even 10 steps, we have been able to get some good information and good model. Yeah, exactly, Harsha. So data is randomly shuffled first, and then 391 batches are converted or built. Okay. Okay. And then I could just evaluate the model. I could just pass the test data. Okay. You will have to do the same reshaping and same kind of scaling. And it can evaluate the complete data for you if it, so you can use the evaluate function, or later you can come up with a predict function, model.predict function, which will give an X data or some test data. It will start to give you the prediction outcomes of it. Okay. So guys, let's take a couple of simple use cases, nothing very complicated. I will try to show you what can go right, what could go wrong. But let's just try to take some simple use cases. Okay. And let's just discuss them, what we can do or what we can try to solve this. Okay. So guys, as you might know, neural network, or not neural networks, actually we could think about any kind of machine learning task, is fundamentally utilizing some kind of a, or like these are still going to be defined well within defined under machine learning itself. Yeah, exactly. The same pipeline or same kind of processing should be done on the test data. So let's say you have your numerical regression task. You could have your classification. So the example that I just showed you, is a classification task, right? MNIST classification, we like to call it. But you could utilize it for purposes of regression as well. So guys, what we will have to do in terms of regression, or what should we do in terms of regression to solve this problem? Predict a continuous value. Yes, the Y outcome that you are predicting is going to be a continuous outcome. Very good. So one of the designs that you will have to think about is, like, see, overall neural network or deep neural network design is not going to change by much. Okay, but one major change will happen, and that should be very obvious to you. Guys, can you see what we are doing here? The final layer is gonna be only one, because you are interested in only single outcome. You will have no activation here. Okay, there will be no activation function. Rest of them can have their activation functions, no problem. Okay, but the final one will not have activation functions. And one another thing, because kind of a regression problem that we are dealing with, the last one that we will deal is something called mean squared error. So if you have done simple linear regression, you will know this. We actually mean squared error. This is something that we utilize. So you could have your deeper layers, okay? You could have your deep hidden layers, that's all right. But the final outcome layer is going to be a single node in terms of regression. No outcome activation function that you will utilize. And the loss should be mean squared error. This is something that you will have to remember. And rest everything will be same. It will calculate the loss, and again, it will try to adjust the weights and whatnot. It will try to do rest of the things would be exactly the same. This is the only major difference. Apart from this, everything is gonna be same. So let me show you how to run this and how to work it. Okay. Now there is this file called petrol consumption. Let me just find this file. I might actually have this file with me. So just give me one moment, guys. Okay, one minute. Let's see. I cannot. Weird. I cannot see the data set. Okay, one minute. There are ways for this. So there is this file called petrol consumption. Let me just figure it out. It must be with me actually, but I have it on multiple data folders actually. So sometimes it is not visible upfront. Okay, so I've loaded the data. Let me show you this data first, because without this data, you will not be able to understand what we are doing here. So okay, I'm sharing my screen once back. Please confirm if you can see my screen. Okay, can you see my screen here?
Yes, sir, we can see.
Okay, thank you. Okay, guys, so this is the data set here. Okay, this is the data set that we are dealing with. A very small data set. Actually, it is mostly utilized. It mostly utilizes some numerical data. Okay, so guys, petrol consumption is the outcome. Okay, this is the outcome. And we have petrol tax, that is a numerical value, average income, okay, paved highways, like in that area, and then how many percentage of people have driver licenses, okay? So this number is of course gonna be between 0 to 1. And based on this, basically we want to figure out what is gonna be the petrol consumption. So it's a simple regression task, basically based on these 4 features: petrol tax, average income, paved highways, and population driver license. We want to give our outcome to petrol consumption. Okay, so now there is an easier way to load the data now. So what you could do is you could go here and you could directly try to upload this data. Now you have to understand this data will not be there for all the time. It does get wiped out from there. So if I go here and if I were to just open it up. Now you can see the petrol consumption file here. So the data is uploaded. Now, okay, now we need to know what is the path. If you want to know, you can go here, and what you can do is you can just do the copy path thing, okay? And replace the path here. This is something that you will have to do. And this is the path, and let's try to read this path from here. Yeah, so we can read this. Now we have read it via Panda, so it directly opens in a Pandas data frame. And this is like the head, so the top 5 values have been shown to you. So guys, what do you notice here? What can we do regression here? So we can separate that's not an issue. We will be able to separate. I know this is not a big data, but we will be able to separate this file. So the idea is using these 4 features, I want to predict the petrol consumption. So let me show you what I am trying to do here. First, what we do is we separate the X and Y. Okay, we separate the X and Y, and then we utilize train test split from scikit-learn model. Okay, and we have taken test sizes 0.2. So 80% data will be given to training and 20% for testing. And I will be using standard scaler. So I think someone was asking, can we use the simple standardization and or scaling or normalization? Yes, we can. And you can see I'm scaling my data. I'm simply scaling my data. And this scaling, of course, has to be applied on the training and the testing data, both of them. So I do this and I scale my data. So this is how my X train is going to look like now. Okay. You can clearly see this, that we are utilizing this, and all the data is between gonna be, because it's a standard scalar. Still, I could make an argument that, okay, most of the data is gonna be between -3 to +3. And almost this would be case for 99.73% examples. Good. Okay, very good. Now, could you explain me what am I doing in the neural network part? So I'm trying to build a deep neural network. You have your input layer where you are taking the data. Okay. So let's say you start with your input layer. No competition happens at an input layer. Okay. And the next layer has a size of 100. Next layer has a size of 50. And then size of 25. Okay. But the final one has to be of one size. So, right? Okay. So yeah, this time I'm going completely with ReLU here, completely with ReLU. Okay, so activations are ReLU and each layer is passed. So guys, now this is the functional approach. So someone was asking, so this is the functional approach. If I do not want to define sequential, you can see I've never defined sequential. So I can directly tell which one goes in which direction. See, in sequential, we did not have to tell this, that input layer goes to dense layer and dense layer 1 goes to dense layer 2. We did not have to do that. But here, because you have not defined sequential, this is a kind of a functional approach we are taking, that we will define functions and we will come up with our own rules. So yes, if there were a custom, some kind of a custom neural network where we were trying to build, we could do that easily we could do that. But let's say we are choosing not to do it right now. Okay. So here I'm defining it one by one on my own. And the final one has one. But here again, there will be no activation function. And I will be using in a mean squared loss. Okay. Okay, one more thing you will have to do is you will have to give a complete part to the model that start with input layer and go all the way till output layer. Okay. And here the connectivity has been shown step by step. So we'll have loss, that's mean squared error. We have optimizer Adam, and again matrix is again mean squared error. And based on this, we can run the training process. One could also print out the model summary. So model summary will give you in a text format what the model is. Model is basically a neural network, by the way. So guys, what's happening here, if I were to ask you? You have your input layer, which is of size 4. At input layer, I told you there are no parameters, no weights, no biases, no calculation happens. Now, the next layer is first dense layer, where we have 100 nodes. So guys, how many number of parameters we will have? Parameters are the total numbers. Okay, so parameters is the count of weights. How many weights you have plus count of bias. Yeah, so 100 into 4, yes, absolutely correct. So in weights will be like total, like 4 into 100 or 100 into 4. So 4 inputs into 100, but biases would be as many nodes you have. So 100 nodes total, right? So you will find we are getting 400 plus 100. And the total number comes as 500, right? And this is why you see number of parameters is 500. Now what happens next? For the next one, why is 5050? Because we have 100 into 50 or 50 into 100 plus 50. What this number will come as? 5000 plus 50, right? And this number will give you 5050, right? And so on, and so on. We will get all the outcomes. Now, why getting the number of parameters is required? Because see, understand, as many trainable parameters you have, that much time it will take to train. Now, this is nothing for the current modern neural network. It's very small. These days we have billions of parameters. This is nothing. Practically 6,851 parameters is nothing for us. Like even for a simple CPU-based computer should be good enough to solve this problem. And then again, I will go ahead and split the data in 0.2. So rather than giving the separated data, you could also just give the validation split. And I have given batch sizes 10, 200 epochs. So it is training the model. Okay, and let's start from the top here. And you will see that because the data is so very less, I don't have that much data. Even in training data, we are only getting like what, some 30 or less than that data. Now you will see that the performance is not going to be that great. Okay, this is going to be a biggest problem. The performance is not that great, unfortunately. You could print out the history, you could save all the history, and you could see how the loss has been taken care of. But overall, you will still see that, okay, fine. The model is trying to do better as it goes. Okay. So validation split, let's say you tell 0.2. Okay, so if you tell 0.2 randomly what's happening is 20% data of the training. Okay, so let's say you have provided the training data. Okay, so imagine you have 50 rows here. Okay, so randomly again 20% is 10 rows. 10 rows would be separated out for validation, internal validation, and rest 40 rows will be utilized for training purposes. It's very similar to the trade test split that we do with. Yeah, it's kind of a random selection. Yes, you are right. So you can see that the blue one is our normal loss on the training data, and the orange one is the loss of the validation data. And you can clearly see the outcomes that they are coming, but beyond like 100 epochs or something, they kind of get flatlined. And one could try to predict the R2 scores and everything, and you will see that the performance is still very bad because the data is very less, guys. I could run a simple linear regression and I could get far bigger answers here, far better answers, not bigger, far better answers here. Because one problem, and this is something I want to tell you, all of you, that if I'm using with deep learning, if I were to use it with deep learning, I do require a lot of data. So like 100x more data, let's say, if I have to say it like that. People do come and ask me that, okay, how much data are we dealing with? So we deal with 100x more data time and again. Okay, on an average, I'm saying. So if in ML, maybe 100 to 500 rows is good enough. Okay, so maybe 500 rows is good enough for most of the machine learning techniques, right? Not for deep learning, not for deep learning. For deep learning, same thing has to be done. And let's say on an average, we would want 100 times more data. So let's say we are looking into range of, let's say, 50,000 rows, or maybe 100,000, 1 lakh, 2 lakh rows to solve this problem, right? Otherwise, it's gonna be really hard for us. And this is what you see. If you do not have good enough data, the neural network performs so very bad, and you can run a simple linear regression here. And this is not even gonna solve as good as simple linear regression. Simple linear regression would have gotten this answer done far better. Okay. But anyways, this is what is the idea of core neural network. Okay. Now, while going forward, again, you have to understand in a webinar, of course, we cannot take care of everything. It is gonna take too much time. But one of the things that I want you to understand, why are we even using or thinking about Keras, is because it becomes easier to work in a very simplistic sense, if I have to explain you, because it becomes extremely easy to work here. And this is what we want to kind of work. And all of these functionalities that we are utilizing, kind of utilizing is just gonna be so very easy to work here. Okay, so very easy to work here. Okay. And again, you have different kind of functionalities that you could utilize, and you will have to experiment. Okay, and various kind of activation, and even data sets. Even if you have to look into various data sets like CIFAR 10 or CIFAR 100, is openly available, not a problem. Okay, so guys, anyways, I think now I have given you a fair bit of idea what we are interested in. And as we have already told you, LearnWay is the right place to learn AI and data science. And if any one of you are looking to enhance your knowledge in machine learning and deep learning, or even full stack development itself, okay, this is something you guys could look into. Okay, all right, guys. I think now we can open up. Okay, now I think we can open up for Q&A. So guys, first I will be taking some question and answers, and then Karishma will join, and she will take further more question and answers, and So guys, let's start with some Q&A here. And you guys can now freely ask the questions and we'll try to. Okay, anyone can ask, so please go ahead.
Sir, this is Harsha. So in regression or classification problem, like how will the model know whether like we got the perfect weight in bias parameter? Like
Sorry, can
exactly
you,
which is the-
Harsha, can you just write that question because your audio is not very clear right now. Yeah, Dan. So the overall purpose of Keras is to design your own neural networks or even reuse neural networks. Okay, there are a lot of standardized neural networks which are available within Keras, which I could just import and start using. So it is going to accelerate your development process. Harsha, so of course, model does not know this. This is something that we will have to classify or understand. What happens over here is, basically what happens, again, it does not know anything to stop. You have to define these criteria. You have to come up with some kind of a tolerance value. You will have to figure out what should be the stop or at what point when you see accuracy or some metrics not changing, how many epochs you wait, and if it does not changes, let's say more than by 0.001, you go ahead and stop the algorithm. So these are parameters that we could define, but again, Harsha, it does not know it. Okay, understand? Neural network is a paradigm that we design things. So definitely, this is something we need to take care of. Okay. Yeah, then so basically, neural networks could be like your building block from where you can build up a lot of complex problem statements, and you could try to solve these issues one by one. You can use it for regression, you can use it for classification, you can use it for unsupervised learning, you can use it alongside with reinforcement learning as well. So neural networks definitely are a common set of techniques that we are using across various classification, regression, and reinforcement learning tasks. Right?
sir, how we can implement clustering with neural network? Like, is it possible to do
Sorry,
clustering?
what to implement? Guys, I will really prefer if you
Clustering.
can write the questions. Okay, I will really prefer that. Harsha, we do not use neural network for clustering problems. Okay, there are clustering algorithms, but okay, fine. You can get embeddings which can be clustered, but directly again for clustering, you will have to use some clustering algorithm. Neural networks directly don't do clustering on their own, but they can do unsupervised learning. Okay, they can do unsupervised learning. Like in a field set of autoencoders, we can do unsupervised learning. Okay. Well, then I will say, yes, it does looks like the accuracy and everything. We have to experiment. But the bigger problem is there are a lot of not problem. Okay. There are a lot of state of the art models. Okay. So many times we are still going to be compared against some of the state of the art models. Okay. How we can extract deep features. So yeah, Harsha, what you can do is you can remove the final layer. Okay. So let's say I will tell you. So let's say rather than having the outcome layer, you get the representation in a vector format and you pass it to SVM. That you can do. You do not take the classification outside yourself by a neural network. You can put some kind of a SVM or something else, and it will use the representation figured out by neural networks, and then it will give you the results. But then this has to be a trained network or trained model first of all, otherwise it would be a little problematic scenario. Okay. But these days, neural networks have over-dominated this space right now. So I will not be saying that it is a great idea to go back to machine learning, because they are, given you have enough data and enough computation, neural networks usually overshadow everything. Most of the machine learning techniques, it is able to overshadow that. Again, the features are going to be the numeric representation that we are going to get from the outcome. Whatever is the last layer, whatever the outcome you get, that is going to be your deep learned features, the final layer, or whatever the last layer you have. There's no command. That's the outcome itself, is those learned features that it has learned. Okay, next question. Okay, so if you want to build a Keras workflow, I think one of the tools, not tools, like I will prefer, like if you guys were to go to Keras, or not Keras, actually Kaggle. Okay, Kaggle is the right website for you. And you need to start solving problems here. If you already know all of this, then you should start solving problems. And on Kaggle, we have a lot of competition. Now, why I'm telling you this? Because a lot of people do end up making their functions, okay, or do come up with their own set of pipelines over there that they can utilize. The other thing you can do is try to implement something via Django server. Okay, try to implement something via a Django server or something like that. Okay, so let's say you take some Keras model, put it in a Django server, and make it live. Okay, now a lot of things have to be done, or a lot of things have to be put together to implement it properly. Okay. Yeah, sure. Yeah, many times we have to deal with it, and I myself have like studied it long time. So I usually keep a lot of data sets around, even to practice on my own. And if someone demands, or if someone likes some data set, I can help them with that. Okay. All right. Next question. So I think if there are no more questions, I think Karishma can talk to you, and she can explain more things about LearnBay and your participation certificates that you are interested in. So Karishma, are you there?
Yes, sir.
Okay, thank you. Thank you, Harsha. Thank you so much. And thank you all of you who attended this webinar. I hope you got to learn something, although still I will say these webinars are very elementary, very initial. Okay, if you really want to tackle it deeply, you should ideally try considering a full course of data science or AI ML. And again, you need to practice. So you should start, if you already know the basics, you should go to Kaggle and start practicing problem statements. All right. Okay, Karishma, what I will do is I will make you the host, and then I will quit the meeting here. Okay.
Sure, sir.
Okay, one moment. Let me just do this real fast.